The time has come, the war said, to talk of lasers. So lasers are fairly recent invention. Well, 1960s they were invented, and they're one of the great, amazing inventions. When they first turned up, but there was an old saying that a laser is a solution looking for a problem. Nowadays, of course, we've got so many uses for lasers, it's not funny. We've got thousands and thousands. So what happens? How does a laser work? Well, from what we're talking for, if we have our nucleus here and our electron here, and it's in a shell and an orbital, and we put in energy, then it'll jump up to a higher orbital. And when that drops back down again, it'll shoot out a photon of energy. That's called, and this photon is going to be very, 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 very specific. And there's a few things about lasers that's very important. The light is coherent. So what's that mean? It goes, all of them are going to have the same peaks and all of them are going to have the same troughs. So every photon is basically going to be in phase. And it's also collimated, which means that all of these are traveling in parallel. So when you have a laser beam coming out, all of the light is parallel, or as close to it as possible, and all of it's going to be in phase. So it's all going to have the same frequency, and it's all going to be exactly in phase with each other. And that's a hell of a trick. So when we're talking about, let's go back to, let's go clear this. So when we're talking about this, what we're actually talking about, so we've got rid of that, is so what we have is we have a tube. I'm going to use red because red's the color for ruby, and ruby were the first lasers. So what we have is we have a whole lot of atoms in here. When their electrons get pumped up, and what we do is if we put electricity in here, these electrons will get excited and they'll jump up a level. Now, if you're talking about a fluoro tube, that's got spontaneous emission. So these, in their own time, will just fall back down. So they get excited, they go up, they drop back down, they'll emit a photon. Now, what happens with a laser is as this photon goes past this atom, it will release that photon. And that photon will release this photon from this. So basically, this is stimulated emission. That's what laser stands for. Light amplification by stimulated emission of radiation, in this case light. So as you can see here, lasers. So what this means is each of these drops back down, and as these photons go along down the tube, they cause other atoms to release their thing. And what we do is we put mirrors on the both ends of this cavity. This one's going to be like 98% reflective. So this one's a one-way mirror. So these photons go bouncing backwards and forwards, releasing more photons, and all of the ones that are in a straight line will come out, and eventually they'll come out after bouncing off the mirrors perfectly in phase and parallel. So yeah, really great invention. We use it all over the place.